What's up, math fans? I came back for Sweater Fridays. I know you've been waiting. All right, I want to talk about recognizing linear functions from a table. So there's a lot of vocabulary. Again, I like to talk about the vocabulary, so you got to listen while you watch. A function is basically just an equation or a relationship between x and y. A function is a relationship between x and y. A good relationship, meaning you're going to see numbers for x, you're going to see numbers for y. As long as the x number doesn't repeat, it's considered a function. So as long as you see 1, 2, 3, 5 here, right? As long as you don't see another 3 here, or another 5, or any x value repeats, you're good. If I put another 3 here, it would no longer be a function. So a function is a relationship between x and y, and it can be shown as an equation or a graph, or both. And I'm going to try to get you to understand that. So I got some relationships here, here, and here. More vocabulary is I said x and y, so this would be my x, this would be my y. X could be called the input. This is my input column. Y is my output. Input versus output. This is called the domain. This is the range. So x is domain, or input, or independent variable. Y is range, output, or dependent variable. And I want to figure out the relationship. The function is the relationship. I want to see what they're doing. Are they, in real life, let's say you see two people walking down the block. Are they friends? Are they boyfriend and girlfriend? Are they brother and sister? What are they? I want to figure out their relationship. I want to figure out their function. What are they doing? So what's going on here? What is their relationship? Let's see. First, I'll tell you a little story. Stage just means, in my mind, stage 1 is my first month. Stage 2 is my second month, etc. So let's say you have a savings account, or a piggy bank, or money under the mattress, or just a piece of paper recording how much money you have. So I want to record my money. So after 1 month, I have no money. After 2 months, I have $3. After 3 months, I have $6. After 5 months, I have $12. I want to figure out what my relationship is. A lot of people like to study this relationship by looking across, meaning looking at x and then looking at y. So if I look at this 3 and 6, it looks like the relationship is easy. You just double it. 3 times 2 is 6. I'm done, right? But that relationship has to be the same for every pair. 5 times 2, is that 12? No, so that didn't work. 2 times 2, is that 3? No, so that didn't work. 1 times 2 is definitely not 0, so that didn't work. So that was too easy and it failed. Sorry. Let me try instead of going across. Sometimes going across is obvious. I made it not obvious on purpose. Let me try going down. If I go down again, well, I made it easy this time. So let's see. From 1 to 2, I added 1. From 2 to 3, I added 1. You can assume I left that hole for a reason. I'm going to add 1 and fill it with a 4. And then from 4 to 5, I add 1. It becomes 5. So that's cool. You add 1 each time. Real simple. How about this way? What's happening this way? From 0 to 3, I added 3. From 3 to 6, I added 3. From 6 to... Oh, is it safe to assume? It's not safe yet, but if you watch the pattern, you're looking for patterns, you'll see what happens here. Okay, it looks like I'm adding 3. It looks like I'm adding 3. If I'm correct and I add 3, 6 plus 3 is 9. And now if I'm correct and I add 3, ooh, I do get 12, so I was correct. All right, so now it's safe to assume my pattern is adding 3. So this number is important and that number is important also. I want to know what my pattern is. My pattern was that the y values go up by 3. What's happening to the x values? They're going up by 1. So that's kind of like, I want to see what's happening to the y, and I want to relate it to what's happening to the x. Up 3, up 1. This is important, okay? If I didn't fill in all the numbers, I would still be able to figure it out, and here's how. You want to figure out, how is the y column changing? How did I get from 3 to 6? And I know it's obvious to you, I added 3. But to prove it mathematically, how do you get from here to here? You subtract. 6 minus 3 is 3. Don't believe me? I'll pick a different pair of numbers. How did I get from here to here? That would be 9 minus 6, still 3. Good, it worked. How did I get from here to here? That would be 4 minus 3, which is 1. So my relationship is the y's are changing, and this little triangle means delta, or change in y, compared to the change in x. All right, my y's are changing by 3, my x's are changing by 1. That is my change, also known as rate of change, also known as slope. If I have a constant rate of change, my slope is 3. Letter for slope is m. So the slope is 3. 3 over 1. 3 over 1 is still 3. 3 divided by 1 is still 3. So my slope, my rate of change, my rate is 3. That's the slope of what? What slope? How could I be talking about slope if I'm looking at a table? The table represents a relationship. A relationship is a function. A function gets an equation. The equation has a slope because the equation can be graphed. You can graph equations. So this graph is going to be a line, and the line has a slope. So all of this, looking at this, if you can look at a table and realize it has a constant rate of change, you know it has a slope. You know it's going to graph a line, a straight line. It's called linear. Linear, all right. I'm sure you've seen my video on graphing linear equations, same as graphing linear functions. How do you write the equation of a line? Do you remember this? Y equals mx plus b. Y equals, you have to know what the m is. We just figured it out, it's 3. So that's 3x plus b. Remember what b is? B is the y-intercept, it's the starting point. It's where the line starts from on the y-axis. Where do you think this starts from on the y-axis? If you remember the story, you're saving money. How much money did you start with? Now, this is a trick. I tricked you on purpose. Tricked you on purpose. After 1 month, you have $0. That's not your starting point. Your starting point is where you start from. Not after 1 month. You didn't start. That's a month passed already. Your starting point is 0. Stage 0. Always remember you need a stage 0. Where did we start from? If this rate of change is constant and I go backwards, I actually started from a negative number. I actually owed my mom $3 before I even started my savings account. So I started from -3, okay? So this would be 3x minus 3. There's the equation. You can write it as f of x equals 3x minus 3 because f of x means a function of x. It's the same as y. All right? That's it. Practice this one, all right? I left blanks for a reason, but if you see it like this, you can't assume it's linear. You can't assume there's a constant rate of change because I need more information to see, oh, 3 again, oh, 3 again, oh, 3 again, okay. That's a constant rate. Here, this tells me nothing. It just changed by, I don't even know, what, 6, something like that? So let me get rid of this. And let's talk about this. New story. Stage in snow. Still X and Y. This time I'm telling you that it is snowing outside at a constant rate. The snow is coming down consistently. So I'm telling you it's linear by saying there's a constant rate of change, aka slope. And because there's a constant rate, I just got to figure out what happened from here to here. 9 minus 3. Hopefully that's 6. 6 inches got added to the ground after how much time passed by? 5 minus 2. 3 hours passed. 6 inches added to the ground after 3 hours. If you reduce this, 6 over 3 is really 2 over 1. The constant rate is 2 over 1. Now you can fill in the table. Usually it won't be this hard. Usually they'll give you more information. But now that you know it's 2 over 1, let's fill in the table. Okay? So instead of jumping, I know that every hour is 2 inches of snow. So I add 2 inches here. 5, I add 2 inches here. 7, I add 2 inches here. Ooh, perfect, 9. I add 2 inches here. 11, and you can keep going forever, and you can keep going forever. The point is, because it goes on forever, I don't have time for forever. I need to come up with an equation. So keep that in the back of your mind. Let me go backwards. 3 inches means an hour before that was 3 minus 2. Not 2 there. 3 minus 2 is 1. And before that, at stage 0 was -1. That means there was a hole in the ground, I guess. Sometimes my stories don't match the actual numbers, but you get the idea. So yeah, there was a hole in the ground. There was a hole, you had to fill in the hole with an inch of snow, and then finally it started snowing, and it built, okay? This is only helpful on a graph. Let me get the equation first. What do I need for an equation? Let's see, f of x equals mx plus b. So f of x equals, what's my slope? Slope is rate of change. Constant rate. How fast is the snow falling? Oh, I just figured it out. 2 inches every hour. 2x. Plus b. B is at stage 0. Where did we start from? We started from a hole in the ground, -1. So my equation would be 2x minus 1. You have to know how to graph this. If you don't, check my video on graphing linear equations, okay? How do you recognize you're looking at a linear function? By looking at the table. How do you recognize it's linear? If there is a constant rate of change. It's linear. Over here, I was watching a movie called Pay It Forward, and there was a little boy in the movie. At stage 0 was the little boy sitting in his room all alone, one person, just the boy. Stage 1, the boy went outside and helped 3 people. He said, I need you 3 people to go and help 3 other people each. So at stage 2, there were 9 people being helped. The rule was for those 9 people to go out and each help 9 people. So at stage 3, 27 people were helped. At stage 4, can you guess? 81 people were being helped. And again, this grows very fast. But let's see if this is a constant rate of change. I get the pattern. There's always a pattern, but is it a constant rate of change? From here to here is 1, that's constant. Here to here is another 1, constant. Another 1 and another 1. This is constant. Looking good. From here to here, add 2. From here to here, what's that? Add 6. From here to here, what is this? Add 18. From here to here, add some other crazy number. This is not constant. It looks pretty, but it's not constant. This one's not linear. Not linear. You only see a linear function if there's a constant rate of change. It's a lot simpler than I'm making it. I just wanted you to understand the details behind it. It's constant rate of change means you're looking at a linear function. The end. Thanks for watching. See ya.